Hey there, Algebra Pros. Welcome back. You know how sometimes you feel like you're missing just one tool in your math toolkit? Like there's this one type of problem you just can't quite get a grip on? Well, today we're going to find that missing piece. We are going to totally demystify logarithms. So here's the game plan for today. First up, we're going to see exactly what kind of problem logarithms were invented to solve. Then we'll break down what a logarithm even is. After that, we'll get our hands dirty with some examples. I'll show you a couple of common traps to avoid, and then, the fun part, we'll see where these things pop up in the real world. Look, you're already a pro at solving a whole bunch of equations, right? You know exactly what to do when you need to find the base, like in a problem like x squared equals 9. But what happens when the thing you're looking for, that little x, is stuck way up high in the exponent? Yeah, think about it. For x squared equals 9, it's easy, right? You just take the square root of both sides. Boom, you're done. But what about 2 to the power of x equals 8? I mean, how do you get that x by itself? You can't divide by 2, you can't take a root. It's just stuck up there. You need a completely new tool for the job. And that, my friends, is where the logarithm comes in. It's the key. Think of it like the perfect countermove to an exponent. It's the tool that was literally designed to solve the exact problem we just ran into. So let's open up this new tool and see what it can do. Okay, so what is a logarithm? Or log for short. Honestly, at its core, it just answers one simple question. And that question is, what exponent do I need to get this number? That's it. Seriously, if you remember one thing today, remember this. The logarithm is the exponent. It's the answer to that question. And this right here shows you the relationship perfectly. These two things on the screen, the logarithmic form and the exponential form, they might look like different languages, but they're saying the exact same thing. Log base b of x equals y is just a different way to write b to the power of y equals x. They're totally interchangeable, just two sides of the very same coin. All right, let's quickly break down the lingo so you know how to read this stuff. That little number down low, the b, that's called the base. Super important. It's the number we're raising to a power. And the bigger number next to it, the x, that's called the argument. That's our target. That's the number we're trying to get to. Now, like any good system in math, logs have a few built-in shortcuts, or, I don't know, call them cheat codes. They're super useful. First, the log of 1 is always 0, no matter what the base is. Why? Because anything to the power of 0 is 1. Makes sense, right? Second, the log of a number when the base is the same number is always 1. And these last two are my favorite. They show how logs and exponents basically cancel each other out. They're inverses. Keeping these 4 in your back pocket will save you a ton of time, trust me. Okay, and before we go any further, just a couple of quick but critical ground rules. The base, b, has to be positive, and it can't be 1. And the argument, x, the number you're actually taking the log of, also has to be positive. These aren't just random rules. They're there to make sure the math actually works and doesn't, break. All right, enough talk, enough theory. The best way to get the hang of a new tool is to actually use it. So let's take this thing for a spin. We're going to walk through a couple of examples right now. Okay, first up, let's evaluate log base 3 of 81. So what's the first thing we do? We ask the question. Okay, the question is, 3 raised to what power gives us 81? Let's just try it out. 3 to the power of 1 is 3. Nope. 3 squared is 9. Getting closer. 3 cubed is 27. Almost there. And 3 to the 4th is 81. There it is. The exponent we needed was 4. So the answer to log base 3 of 81 is just 4. Okay, ready for level 2? Let's try one that looks a little trickier. How about we evaluate log base 4 of 1 over 16? Don't let the fractions scare you. We start with the exact same question. 4 to what power gets us to 1/16? Now, just think back to your exponent rules. We all know that 4 squared is 16, right? So how do you get 1 times over 16? You just make the exponent negative. So 4 to the power of -2 is 1 over 16. And that's our answer. It's -2. Okay. Every new tool should come with a big warning sticker on it, right? So think of this next section as the owner's manual. We're going to look at a couple of super common mistakes so you can steer clear of them right from the start. All right, pitfall number 1. What if someone asks you to find the value of log base 2 of -8? What's the answer? The answer is, it's a trick question. You can't do it. The answer is undefined. And here's why. Just think about it. Take the number 2. Can you raise it to any power at all and get a negative number?
2 squared is 4. 2 to the minus 2 is 1/4. 2 to the 0 is 1. No matter what you do, you can never, ever get a negative result from a positive base. So the rule is simple. You cannot take the log of a negative number. Period.
And the second big mistake is treating log like it's a variable you can multiply. It's not. You would never look at a square root sign and think it's multiplication. It's an operation. It's the same thing here. Log is a function. Log base 2 of 8 is a single command, a single instruction. It is absolutely not log times 2 times 8.
So right about now, you're probably thinking, okay, this is cool, I get how it works, but when am I ever going to use this? Fair question. Let's talk about why this actually matters and see where this supposedly abstract math pops up all over the place.
It turns out logarithms are kind of everywhere, especially when we need a way to talk about things that have a huge, massive range of values, from tiny to gigantic. I'm talking about things like the Richter scale for earthquakes, the decibel scale for how loud a sound is, and even the pH scale for acidity in chemistry. All of those, they're logarithmic scales. So what does that even mean, a logarithmic scale? Well, it means that when you go up by one number on the scale, say from a 6 to a 7, you're not just adding one unit of power. No way. You're actually multiplying the power by 10. Every single step is a 10x jump.
This is where it gets really wild. Take the Richter scale. An earthquake that measures a 7.0 is not just a little bit worse than a 6.0, it is 10 times stronger. And an 8.0, that's 10 times stronger than a 7.0, which means it's 100 times stronger than a 6.0. See? That is the power of logarithms in action. It lets us take these enormous, mind-boggling differences and put them on a nice, simple scale from 1 to 10.
So there you have it. You've officially added a brand new, super powerful tool to your algebra toolkit. You can now read and understand logarithms. But what's next? Well, now that you can read them, how about we use them to finally solve those tricky equations we started with? Because that's where the real fun begins.